Guys, welcome to YouTube channel Foundation JEE. Today's lecture is continuation of our previous lecture on sound. In last lecture, we guys learned about definition of sound and C for propagation of sound. Medium particles are required and also discussed the characteristic of sound like wavelength, frequency, velocity and time period of sound wave. Guys, in this lecture we will discuss about pitch, amplitude, loudness, note, tone and supersonic sound, or you can say sonic boom. Okay, so guys, here now time to see first pitch. And pitch, guys, suppose two voices are produced by two different persons, then due to variation in frequency of sound in medium, our mind distinguish two different sound. So basically pitch depends upon frequency of sound in medium. When frequency of sound in medium is more, then pitch is more. Okay, so guys, consider here, suppose one person is speaking and medium particles are vibrating like this. Okay, so if this one is density of variation of medium particle, or this one is distance. Okay, now this one is normal or mean position of density. Okay, so what you see guys here, this one, when we go next, then we read this distance is known as amplitude. Okay, so suppose other person is speaking, okay, however he is maintaining the same amplitude. However, guys, the number of frequency generated by the sound in medium is more, then his pitch is more. Okay, so this is person 1 voice, or this one is person second voice. So what you see in this one, the frequencies are more in compared to this one. Okay, so guys, when we speak, then our mind interprets how frequency it gets. If somebody is speaking with high pitch, it means he is generating more number of frequency in the medium. Okay, this one is more. Okay guys, next we see what is amplitude. Okay, see amplitude. Okay, so it is maximum displacement of medium particle from its mean position due to sound. Okay, so we read in our earlier lecture, guys, how sound is propagating one place to another place. Okay, see, suppose this one is a medium particle here, 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 here. Okay, now suppose this one is a here a speaker. Okay, loud speaker or source. Okay, so what's happened when this one generate a sound, then it's created a pressure on the medium. So what's happened, this particle push this one particle, and again this one push this one, and this one, and again this one, and this one. So what you see, it pushes, first pushes the second particle, then again it return back to its original position, go back to its mean position like here, then again it's oscillate. Suppose this one particle is connected with a string, then what's happened, it go here and strike the other one particle, then come back and again go at this extreme position, again return back, again go, and this cycle continue. And after elapse of some time, when the source of sound stops, so it come to its again normal position or equilibrium position. Okay, so such way the sound is propagating in medium. So what you see, guys, here, suppose one particle is connected with this string, so it will go here. Okay, so this distance straight line, okay, is known as amplitude. Okay, so when we draw the variation of density of medium due to pressure wave or created by loudspeaker here, so what we see, suppose here if the medium particles are oscillating like this one. Okay, so how this is happening, suppose initially this one is at here position, extreme position, suppose this one. Okay, then time lapses, then what you see, it will come to this line which is a normal, or you can say equilibrium position. Okay, so with respect to time, if you see, this one is a density. Okay, so guys, you can see here, if the particle is moving first in this direction, okay, due to sound wave, then it is come to extreme position, then again this particle return back, so come to this equilibrium position, again it is coming in this position, so we say this is going in down direction, again it is returning back, so again it is coming this normal or equilibrium position, again going to high position. Okay, so in last lecture guys, we saw this distance is known as wavelength, or you can say the consecutive distance between the two crests. Okay, or trough here, this one is known as wavelength. So we have already discussed in last lecture. If you guys did not see it, then please see, the link of that lecture is given in description box. Okay, so guys, what you see, the this distance is known as amplitude, which is denoted by capital A, or this one is also known as amplitude. Okay, so by looking this waveform of sound, we can also define amplitude. It is maximum displacement of medium particle due to sound from mean position, either crest or trough side. Okay, so see, this one is a crest side, or this one is a trough side, so this one is a maximum displacement here, or this is maximum displacement here. Okay, so now hope the concept of amplitude clear to you. Okay, so next we see guys the loudness. Okay, so suppose here is a drum. Okay, now this one is its diaphragm. Okay, now suppose you have a stick. Okay, so if you stick with a little force, then you will hear less sound. Okay, less sound. Okay, now suppose you strike this drum with greater, or you can say harder force, then sound will be generate more. Okay, so more sound generated. So this time you say the loudness of sound becomes more. Okay, so guys, what's happened in waveform? Suppose now this one is a graph, or this is density of medium, or this is distance. Okay, so suppose medium particles are start vibrating like this one. Okay, when you are striking the drum with a little force. Okay, and when you strike the same drum with a higher force, okay, then what's happened this time? The same variation of medium particles now see increases. Okay, here you can see. So what's happened here? This is, if say amplitude A1, or this one is amplitude A2. Okay, so you can say A2 displacement is more than A1. So we finally say when medium particles are vibrating with higher amplitude, then sound is louder. Okay, so guys, next we will see tone and note. Okay, tone. So when sound created by source has one steady frequency is known as tone, or guys, the second one is note. When sound created by sources have more than one frequency is called note. Okay, so in case of note, the sound may be pleasant or noisy. Why? Because suppose if there are several people in a hall or they are start speaking. Okay, so what's happen when one person hear the sound, then several frequency interpreted by his mind, then that time he will say the sound is noisy. Okay, now suppose if you are a musical hall or somebody is playing with piano and trumpet, tabla, etc. So that time also different frequencies are created or your mind receive the sound wave, however you feel it pleasant. Okay, so depends upon the frequencies generated by the sources, we can say the sound is noisy or pleasant. Okay, intensity of sound, so it is power passing per unit area normal to surface is called intensity of sound. Okay, guys, intensity is represented by capital letter I, or it is proportional to a square, where a is amplitude of medium particles. Okay, now as we say this is power passing per unit square, then this is W is watt, and when we divide it by meter square, then it will give you the unit. However, we can also measure it into dB, or you can say decibel. Okay, one important fact, the sound speed depends upon temperature of medium. Okay, so normally guys, the sound speed in air when temperature is 0 degree centigrade, then it is 331 meter per second. Okay, however, when you measure the speed of sound at 22 degree centigrade, then it is 344 meter per second square. Okay, so you remember this fact, when medium temperature increases, then speed of sound increases. Okay, now guys, next we see the sonic boom. Sonic boom, when an object moving in air and its speed exceeds the speed of sound in air, that is 344 meter per second at 22 degree centigrade, then speed of object is called supersonic speed, and sound produces by source. Here object is called sonic boom. Suppose this one is a jet plane here, which is moving with supersonic speed. Okay, now the sound produced by this jet plane or aircraft is known as sonic boom. So it causes sharp variation of air pressure, or you can say it produces large amount of energy and louder sound in medium, which causes a shock wave, and it may damage glass, window or wall of house. Okay, hope guys now concept of pitch, amplitude, loudness, intensity of sound and sonic boom clear to you. Guys, if you think this lecture is informative for you and others, so please like and subscribe this video, and also share this YouTube channel, Foundation JEE channel, to your friends and family, so they also get benefit from this channel. Guys, in next lecture we will discuss about reflection of sound, echo, reverberation, etc. So if those guys who did not yet on their YouTube notification, so please on YouTube notification, so that whenever I will upload the next lecture, you will get the notification. So thanks once again for listening and watching this lecture. Have a nice day. Thank you.